12.2 single slit diffraction plus Young's fringes. Now you may be feeling a bit confused, having done Young's fringes, Young's double slits, and then single slit diffraction, what happens when you've got both. So the picture here shows you exactly what you would get when you've got both. So we're going to have a brief look at that. So just to recall, Young's slits, the equation for that is that the width of the fringes is given by lambda d over s. So lambda for the wavelength of the light, d is the distance to the screen, s is the spacing between the two slits. The single slit equation, on the other hand, is w is 2 lambda d over a. So got a factor of 2 in there. Remember the central fringe is much wider than the others in the single slit pattern, and instead of s underneath we've got a, the aperture, the width of the slit, not the distance between them. So here's two slits. So the distance between the slits, the average distance, is s, as used in Young's equation, and the size of a single slit, a, is as used in the single slit equation. So if you have a bright light, you can get both happening at the same time. So let's assume first of all that the slits are closely spaced, so s is small compared to the aperture. So what you get is both effects superimposed on top of each other. So Young's slits formula, w equals lambda d over s, gives you the spacing between the fringes. So the dotted lines here represent what you would get just with the Young's slits pattern. Okay, so remember, equally spaced, equally bright. But the blue line here, which goes up around there, is the single slit diffraction pattern given by this formula, w equals 2 lambda d over a. Now, what you get as a result of having both patterns is that the single slit diffraction pattern acts as the envelope, the limit of where the Young's slits pattern can form. So as you can see, the blue line has sort of cut the Young's fringes down to a smaller size. So the Young's fringes have to fit inside the blue envelope. Okay, so you get the wide central fringe and then the dimmer ones either side. If, on the other hand, you have a large s in relationship to the aperture, so here the slits are much further apart compared to the size of each slit, you then get a pattern that looks more like this. So the width of the fringes, the Young's slit fringes, are between two of these fringes here. Okay, lambda d over s. S is big, therefore w is small. But the single slit pattern, w is 2 lambda d over a. We've got quite a small value of a, so w is big, so quite wide here. And again, the single slit diffraction pattern forms the envelope, the limit of where the Young's fringes can be. So what you see on the screen is a pattern like this. So you see the Young's fringes, and then they get dimmer and brighter again, and that pattern is controlled by the single slit diffraction pattern.